Okay if I sip coffee during
Yes. This is a very, very informal meeting,
okay.
not formal. I would like to introduce by saying that this year is the 50th anniversary of the Environmental Division.
Mm-hmm.
But along with it, it's also the 50th anniversary for the U.S. Environmental Protection Agency,
Yes.
the NEPA Act, as well as Earth Day. Okay. So we are not only celebrating the Environmental Division, but we are also celebrating 50 years of anything that's environmental that has been going on. So with that, if you would kindly introduce yourself.
Okay, I'll give you a 1-minute background. Right now, or for the last 35 years, I have been at Lehigh University in the Department of Civil and Environmental Engineering. I'm also an honorary faculty of the Department of Chemical Engineering. Both. By training, I'm a chemical engineer, so that's there. But chemical engineering has a huge span. Briefly, my entire career, although I didn't kind of foresee it when I was studying chemical engineering, has revolved around water. I have been probably involved in every possible aspect of water problems, water crisis, water science, water technology, and I still keep enjoying it because it's a very complex thing. Which I didn't even imagine when I was getting into this field. And in my work, I basically apply, I would say, fundamentals of chemical engineering principles, physical chemistry, to solve problems, to characterize water-related problems, and also to create sustainable materials and technology. That's what I have been doing, and quite naturally, I do other usual academic things. During my tenure at Lehigh, we have an environmental engineering program, which I kind of co-founded, which offers BS, MS, PhD, all 3 degrees in environmental engineering. So that's a big plus for me.
That's great. That's great. So you mentioned water, and I was looking up some of your work, exceptional work, and what caught my attention was your work on arsenic related water chemistries, and also some of the work that you have done in India for arsenic removal and some of the arsenic belts in India. Would you like to highlight a little bit on that?
Yes, that has been an ongoing thing. It is still going on, but it is not just limited to arsenic now. It started in 1995 to be kind of very kind of specific. Besides arsenic, we also do fluoride and iron removal, and also the salinity removal. But over there, it's not only in India, Bangladesh, Cambodia. And we also did work, but it didn't go quite far because of other political situations in Kenya and Ethiopia. Basically to provide safe drinking water to the people. Not only that, creating a technology to the point that local people can take advantage of the technology, and can they build an economy around it, which means providing employment and things like that. For arsenic, the way it happened one of my areas of research used to be, and still is, trace contaminants removal. Like tiny, it may be chromium, it may be lead, it may be arsenic, it may be fluoride, it may be many other things. Something happened there, so I was kind of drawn into that. Some people kind of took me there to take a kind of stock of the situation. And quite naturally, I was looking for a solution, and I'm originally from there. And one thing led to the other. We saw many shortcomings. We created a material, arsenic selective material, which can be regenerated, reused. And then we created a called foundation, it carries the Sengupta Foundation. That was the first thing. That is in USA. Then we went to India and created an NGO called Technology with the Human Face. Then we created a social enterprise company. It's called Drinkwell. Mm-hmm. Now, through Drinkwell, we got some money from US State Department and Department of Science and Technology in India. We now manufacture this new, we call it hybrid ion exchange nanomaterials or nanotechnology in India, using people there, using raw materials there. We use those materials in India, obviously in Bangladesh. We have done that in Cambodia. In fact, we even exported from there some materials for some trials in USA and Mexico. So it is other way around, It is not a huge organization, but it is growing, and the whole purpose is to kind of provide needed technological service in the water space. It's not limited to arsenic and iron, arsenic and fluoride now. We also do other things, we are trying to create technology there. So that's the part that's related to research, but that's more like taking research outdoor,
Yeah, so that was my next question. So what is your thoughts on, there is a lot of fundamental research, especially in the environmental field, that goes on. How much of it do you see get out of the lab and go in the application domain? Or what do you think we still can do about that sort of work? Because being in sustainability research for some time, we know we do a lot of things, a lot of policies, but how do we take technology and policy and how can we join them together to get it out in the field so that people can really benefit from that?
In a way, the answer is yes, it can be done easy, but other way it's also difficult. I don't think it is the lack of knowledge. I have also written, in this area, I call it, people do not need breakthrough technology. They need breakthrough solution, Like we have a tendency, if I'm doing research on superconductivity or nanotechnology or graphene, quite naturally for understandable reason, we want to embellish or we want to inflate that, okay? But that, and maybe we get a lot of citations, that justifying our position and maybe grants too. But that doesn't really help the other end. It doesn't even go to the other end, And in other words, it is not the lack of science part, it is the mindset. And I primarily say two things. One is the tenacity, that means the resolve, This is not just you try and you win, This is like a very convoluted path. Every day you learn, then change, but it's fun. But without tenacity or resolve or that kind of attitude where failure is part of the process, but you still move forward, you need that. And maybe that's lacking for good reason, bad reasons, who wants to spend so much time, doing this? It doesn't go too far. Even in USA, it's very difficult. The second part, I call it simple thing. I call it humility, that when I write a paper or you see paper, or you write a paper, it starts with, there is a problem there and this is the solution, Maybe that is true, but the writer knows, everybody knows the solution is not just the end of the paper. So there has to be that sense of humility that you go and learn more, change it, learn more, change it. And our system here, maybe other places too, it's not designed that way. You do not get any much credit or push, from other people that go and do that. So it is not the lack of knowledge or something. It is, I'll say, it's individual thing. Some people do that resolve part or tenacity part. And the other thing is the humility part, that you are modest enough to go to a remote place and have a mindset to learn from simple people. Because you do not know everything there, because they're the ones who will be running the plant, who will be, in the absence of that humility, it's not that easy,
Mm-hmm.
So these are two things, but nobody probably, it's
No,
not
no,
that,
I
not that
completely
glamorous,
agree with you on that, because there are many things to be learned from common knowledge and common people than what we give credit for. So just going back to the technology that you talked about, would you kindly explain a little bit more details of the technology that you work with?
Okay.
I know it may be vast, but any of the technologies that you think have been breakthrough in your career that has created positive impacts?
Yeah, I've been an academician for a long time, so written, as everybody does, a lot of papers, over 100. I have probably a dozen patents, but the one I take credit in the academic world, not academic, so professionally. Finally, besides the papers or editing books, I single authored a book. Its title is Ion Exchange in Environmental Processes. It took me 5 years to write it. It was published by Wiley, and I believe, or maybe hope to believe, this book will outlast me by 5, 6, 7 decades. People will read it because that's the way so that's something I take pride, not because it cannot be done, but it takes a lot of patience and among other things. So this is something which I believe will remain, and that book contains, fundamentals and also many technologies. Mm-hmm. The technology part, obviously the arsenic fluoride part, they are the most visible ones because people are benefiting, it's a material which probably has been used, this hybrid ion exchange nanomaterials, maybe by 2 million people probably drink safe water, through this in maybe 6, 7 countries, So from that point of view, yes, this is something significant, And again, it didn't happen overnight, We went through a lot of trial and error, did something, and still improving, doing things. But we also did quite a few other things, in the area of desalination. Now we are doing something with, it's called brine management. You're in Texas A&M, you are not exactly in the shore. If you kind of remove salinity, you end up with brine reject. What happens to it? So we are involved, but that in America, there are certain difficulties, which is even more difficult than working in Bangladesh. People don't understand that's because the regulations and like, for example, El Paso, I was interested in working there, because they have a plan, that. It's not easy to work in America either, because there are so many kind of hoop you have to jump, and even getting a simple letter, from a water company is not easy, okay? But again, as I said, tenacity is needed, but we also do work in other areas, besides arsenic and fluoride, which are the most visible ones. We have been involved in processes which I believe, like I call it in China, the company is trying that. In India, maybe we'll soon do that. That's for low TDS, lean brackish water, 1000 ppm. We have developed a process. We also have a patent that with carbon dioxide alone, we can desalinate the water. You do not need electricity. And that carbon dioxide can come from you're familiar with anaerobic digester and things. When you burn, you get electricity. And then basically you are discharging carbon dioxide rich gas. This is much better than a flue gas from a coal-fired plant. So from a sustainability viewpoint, since you work in the area that's close to everybody's heart, so that carbon dioxide is a huge amount, I see. I mean, I can make use of that to desalinate the water, which we call secondary wastewater after treatment from municipal. So we have tried that in Bethlehem wastewater. We have a grant to try that in Allentown. I think it has a huge prospect in every country. Here, the progress is slow in the sense, in order to go to the Allentown plant, I need a permission. Now I have money, but now also it's a COVID-19. So yes, we have done arsenic fluoride, we have done materials, we have shown that you can apply it, you can improve the economy, you can employ people. There are plants which have been running for 15 years, in remote villages. So it cannot be a fluke. But there are other areas, where also I believe we have a prospect strictly from sustainability viewpoint, that as I said, with the carbon dioxide, if I can desalinate, it's not it's a lean brackish water, like a 1,000 ppm TDS, we can eliminate pretreatment. It's a slow process. In China, a company is trying that.
I think that is very important for us also to understand that the low brackish water is probably one of the greatest sources of drinking water around the world, given that we are running out of groundwater resources, increasing population, and most of the population in the world live on the coast, where we have either brackish or saline water. So I think that is a very important contribution. But also in terms of shale gas wastewater, that's where I have some work experience. We are working on a project on shale gas wastewater. And Pennsylvania has been also shale gas activities are going on. And have you had any experience in the shale gas wastewater treatment area?
I am assuming that since you said all these things, it's part of your area, you are quite familiar with the problem. Yes, we have been. The TDS of that shale gas water in Pennsylvania is 170,000 ppm.
Exactly.
And right now in my lab, we brought in maybe 5 big containers, still 2 are left. And one of the thesis was on that, And if you're familiar with Marcellus in Pennsylvania, it has barium, strontium, and also the radioactivity.
Yes.
And we created a process because that was how the problem was kind of thrown at us. The can you solve, with use of, I call it, like available natural wastewater, acid mine drainage. We have a patent on that too, and we are going to publish a paper like in a few days because it's all through now, about removing barium, strontium, and radioactivity. And radioactivity kind of varies there because sometimes it is there, sometimes it is not there. So it's very difficult to treat because you don't know it priorly, okay? But this process will take away because whenever it is there, it will remove it. Otherwise, it will let it go. So yes, we did something from a different perspective. The company I was working with, they were interested, but the gas price dropped and that. So company basically kind of closed down. But I still believe this is very good. If that's one aspect of it, that we remove barium, radium, strontium, okay? But the TDS remains the same because it can be, that's what I was told. I'm not expert in petroleum, whatever gas extraction. Then it can be defed as for flow injection, one you take out. But the other one we have is that I can start from 150,000 ppm water. And this is what we are working on, and maybe it will take some time. We can bring it down to 250,000 ppm, which is like for crystallization, that's the concentration they want, in a process. Obviously you need energy, but the waste energy, you need only waste energy from there. So that's the one which is ongoing, and I love it because it addresses both sides, but I have not been able to make it move ahead, like because the companies are kind of down and that art I don't have, in India or Bangladesh, that's much easier for me. I just go there and start working, and then if the government comes in, I explain this, that, but here, this is a completely different thing, But I believe if you're interested in shale gas, we're talking more formally for AIChE. If you have any outlet, I think I can play a role, at least the process we can try, that take the water, recover the water, kind of distilled water. It's a simple process which doesn't lead to calcium sulfate. In other places, there are some kind of a fouling effect there. You are probably familiar with the membrane distillation.
Yes.
And membrane distillation has certain advantages. Disadvantages too. You need preheating of the water because it works on vapor pressure. In our case, it doesn't need it. You can take the cold water, do it, and then get it concentrated. So again, this is not an accomplishment at this point. It's a journey, but so far I'm enjoying it, you know.
So what do you think is there for the next generation to learn from your experiences in the environmental area?
You know, I do not want to say big things, but again, these things have been said by so many people before me, not in the field of engineering alone, that if you believe in something, if you think you have an idea, there will be resistances, there will be problems, but still you have to proceed, you know. That's what it takes, you know. So again, I'll come back to that. And there will be oppositions because so many people are doing different things, right? So everybody has a vested interest, you know. Everybody thinks reverse osmosis, the point you made, you know, I'm very delighted that you made the point that most of the brackish waters, groundwater, they're lean brackish water. You don't find too many papers where people are working on that. They go to seawater right away, and there are only 2 seawater distillation plants in the entire United States, and maybe 3 now. Yeah, maybe 3. Okay, also 3 plants in the whole country, like United States. So this is not the main issue. Main issue is how we recover the water from municipal wastewater treatment plant after treatment, because that's much cheaper than treating water. And now people are understanding, getting into that, you know, and there the thing is that, can you recover 90%? Can you use carbon dioxide and things like that, you know? So for the next generation, I'll say that result part, tenacity part, humility part, they were always there. But fundamentals, understanding the fundamentals, that still remains, you know, this, you have done PhD, you have learned many big things, but the basic undergraduate education, you know, do we understand mass transfer? Do we understand conservation of energy? Can we make up that this is in violation of second law of thermodynamics, so it cannot work, you know? I consider that to be, that's the, my line to all the graduate and undergraduate students is fundamentals are the most practical knowledge one can ever have, you know. All those working in group, going to the site, they're there, you know, they will always be there, but it cannot be in violation. So grasp that well, be it part of your second nature or DNA, then you will get an answer from inside, you know, from your inner voice, you know. That
one of the things that I like that you said that we do a lot of theory, but the solutions approach is probably putting the pieces of the knowledge that we have together. And that has been one of the core areas of sustainability research, where we have to put in economic, environment, societal together to give a solution that is useful for the people that we serve as scientists and engineers. So I think we are about to run out of time, but this was very, very insightful, and I would like to request your permission, as well as AIChE is going to contact you with a permissions form to be able to use your this discussion in some form through the AIChE website and other places, and you'll be notified of all the areas where we will be publishing this information.
Very nice. You know, thanks for reaching out to me, and maybe at some later time I'll know more about you, more of you, you know, which is